Hi, Julian.
What?
Hello?
Can you hear me?
Yeah, I can hear you just fine. How are you doing tonight?
Okay. I'm doing good. How are you?
Good. Okay, shall we just dive into these two documents here?
Yeah.
Okay. Are these circled answers your answers, or the teacher gave you the correct answer?
They're mine.
They're yours. Okay. Tell me why A is not a polynomial.
Because it has a letter as an exponent.
Yeah, it has a variable as an exponent.
Yeah.
Why is D not? You actually did that because they have fractional exponents. Why is C not?
Because it has a fraction.
Yeah, it's 1 over. In other words, the bottom is a polynomial. But if I really wanted to write this expression properly with an exponent, I would write it like this.
I believe it.
And that's a negative exponent. Because it's a
Okay.
negative exponent, it's not a polynomial. Which polynomial can be multiplied by x plus 4 to produce that? How'd you do this?
Because 3 times 4.
Yeah. Oh, so you kind of back solved it, in other words?
Yeah.
Okay. Let's teach you how to do it properly. If that times one of these answers is equal to that cubic function, then if I divide this polynomial by x plus 4, I'll get the answer they're looking for. So we want to do long division. We want to put the polynomial in here. And we want to divide by x plus 4. Do you know how to do these? Do you know how to do long division with polynomials?
I don't think so.
Okay, it's relatively straightforward. It's not much different than long division regularly. You focus on dividing the x into the 3x cubed for starters. What's that?
I don't know.
3x squared.
3x squared.
In other words, x times that has to equal this. So x, when I divided it, this is what we were doing.
Okay.
And then that's got a 1, so I subtract the exponents, so that's 3x squared. Okay, now, and I don't worry about the 4 at that point, but now I take my 3x squared and I multiply it by both terms.
Yeah.
Subtract, just like you would with long division. This goes to 0. This is 4x squared. Bring down the 16x and repeat. Stir and repeat. So what's next?
X plus 4.
Well, now we have to divide x plus 4 into that part to get the rest of the answer.
Okay.
So do the same thing we did when we tried dividing it into that.
So is it x, 4x, plus 4, 8, 12,
Just
4?
4x. Just 4x. In other words, is all we're doing at this stage is dividing that into that.
Okay.
And we get 4x when we do that. And again, just to check, make sure that that x times that 4x gives you 4x squared, and it does. Now, you multiply it by both terms, and notice that we have a 0 remainder, which means that it divided perfectly. If there was a remainder, then that x plus 4 would not be a factor of that polynomial. But since it is, when that was the answer, And of course now what that means is that answer times x plus 4 is going to equal that polynomial that's in the middle there. So long division is just like regular division. It's really no different. I want to divide 3 into 123. I divide 3 into 12. That's 4. I multiply 4 times 3. I subtract, bring down the 3, divide it again, multiply it, got 0 remainder. 41 is the answer. Have you learned synthetic division yet?
No.
Okay. Because the other way, that's actually a little easier for dividing that polynomial by x plus 4 is with synthetic division. And they'll teach you that. I don't know when. Maybe not this year. What grade are you in? What year are you in, Julia?
Freshman.
Freshman in high school? You might get synthetic division, maybe this year, but I doubt it. Maybe next year. You'll get it next year for sure.
Okay.
What are the zeros of that function? No, not that function. What are the zeros of this? Notice that that's not a y. It's x equal that, not y equal that. That actually makes quite a difference. So how do we figure out the zeros?
U minus x?
Yeah, leaving 0 on the left side of the equation.
Yeah.
What's on the right side of the equation?
Minus.
No, we got
X?
a plus. We got a plus 7x minus
6x?
Yeah. Okay. Now, what it means to find the zeros is if all your variables are on one side and zeros on the other, solve this equation and you have the zeros.
Mm-hmm.
How do I solve this equation?
I don't know.
You want to factor it. The reason you want to factor it is because when you have 0 on one side of an equation, if I can make the other side the product of two things, then I can solve it. In other words, if I tell you, or if you tell me that AB equals 0, then I know for sure that either A is 0 or B is 0.
Okay.
If you tell me AB equals 2, I can't solve it. I have no way to solve for A or B. But when it's equal to 0, that's a very special case, because only 0 will multiply to equal 0. There's no two numbers you can get where one of these isn't 0. Okay?
Okay.
So, when we see a quadratic equation, even without the constant, that's still a quadratic, and 0 on the other side, our solution is to factor. Well, how can I factor that? What's the first step in factoring? Pull out a greatest common factor, if you can. Now, with a lot of quadratics, if I add a number here,
Is 3?
I can't pull out a greatest common factor. But
Is 3 a greatest common factor?
Yeah, it is. Well,
Okay.
no, it isn't. 3x is.
3x.
When you divide both terms by 3x, what are you left with?
7x
Plus.
2.
Now I've got the product of two things equaling 0.
Okay.
So what are my solutions?
Is it 3x equals 0?
Well, that's one. 3x equals 0, meaning x equals what?
0.
And 7x plus 2 equals 0. In other words, we always solve it by setting each one of them equal to 0.
Yeah.
And then x is equal to what?
0.
No, we have 7x plus 2. Well, yes, we do have an x. That's one of the solutions, x equals 0. But there's
Yeah.
another one, because there's 7x plus 2 equals 0. How do we solve that for x?
Divide by 7?
Well, first
Or
let's
minus 2, actually.
minus 2 and then divide by 7.
Yeah.
So which answer has that as a solution and that as a solution?
D. Okay.
Explain what the zeros of a function are. What are the zeros of that function right there I just drew?
The 2
places
points
where it crosses the x-axis.
Yeah.
Because y is equal to 0 there. In other words, if I give you a quadratic like this, y equals x squared plus x minus 2, well, I can draw it, I can graph it, there's the x-axis, there's the y-axis, and the zeros of the function are where y is equal to 0. So I make y equals 0, factor that into x minus 2 times, x plus 2 times x minus 1. Then I set each one of these equal to 0, so my two solutions would be x equal minus 2 and x equal 1, which would be the two places it crosses the x-axis.
Okay.
That's how you want to explain it. And I despise questions that ask for explanations in English, but what can you do?
Yeah.
You gotta live with the teacher you have, huh?
Yeah.
4 is pretty easy. What do you do with 4?
You just add the
Like
common, whatever.
Like terms.
Like terms.
What's the solution to this?
4a squared minus 5.
Oh, not that one. The one I just wrote.
Oh. A to the 5th.
No. A squared times a to the 3rd would be equal to a to the 5th. In other words, when you're multiplying, you can multiply non-like terms. When you are adding, you can only add like terms, and these aren't like. That's an apple, that's an orange. Or that's a pear, and that's an orange. So this doesn't simplify. It's a squared plus a cubed.
Okay.
So you can only add or subtract like terms. Well, one like term is the a squared term.
Yeah.
We got 4 of those. We got 3 there, we got 1 there. So that's where we get the 4a squared from. How many ab terms do we have? And what is their, when you combine them, what are they?
Minus 5.
Because we have a minus 7 and a plus 2.
Yeah.
About the b squareds.
Minus 6b squared.
Because when we remove these parentheses, this minus sign is what we are left with. In other words, when you have plus a minus, you have a minus. Okay. What'd she do wrong?
I think she subtracted wrong.
Where?
Minus
Which term?
the bottom term.
Well, I don't know what the bottom term is. In other words, did she subtract the x cubes wrong?
Yeah.
Not really. 3x cubed minus an x cubed is 2x cubed.
Oh.
7x squared?
Yeah, she subtracted that wrong.
Yeah, there's no other x squared.
Yeah.
So that should be 7x squared. So that's one mistake. What about the x term? Starts with a minus x and
Should it be minus 2x?
Well, hold on. Start with a minus x. Just a second. And she is subtracting a minus 4x. Right? Like that?
Yeah.
So what's that equal to?
Minus 3x
Plus 3x.
plus 3x.
These two minus signs become a plus. So you
Okay.
really have minus 1x plus 4x. Same as what is minus 1 plus 4. It's equal to plus 3.
Okay.
Okay. And then she got the number right. But she's got this term wrong and she's got this term wrong. So if I was explaining this, I would be a little more specific. I would say she subtracted the x squared term wrong and the x term wrong.
Okay.
Find the correct difference. We just did. Well, maybe not. Let's go ahead and write the whole thing out. So what's the correct answer?
Let me figure it out.
Remember, the only two terms that she got wrong are these two terms here.
Is it 2x cubed plus 7x minus 3x? Oh, x squared.
Plus 3x.
Oh yeah, plus 3x.
Plus 2. Remember, minus x minus a minus 4x was 3x.
Yeah.
Okay. All right, next document. Oops. Okay. Find the product. I'm just going to cover up these answers just so I can tell. I mean, I know you have it on your end, but work me through how you multiplied these two together.
Okay. B times B is B squared. B times negative 2 is negative 2B. And then 9B, I think.
Mm-hmm. In other words, you're taking every term and multiplying it by every term. They call it FOIL. They call it FOIL, but I really prefer to call it every term by every term. Because if I have an A plus B plus C times an X plus Y, this is every term by every term. FOIL doesn't work for a trinomial times a binomial. Whereas every term works for this and this.
And then is it minus 18?
Yes. Now simplify that.
B squared plus 7B. minus 18.
Good. Okay. About this one. And I would also suggest being methodical. In other words, not methodical, but using the same technique each time. In
Okay.
other words, don't start out multiplying those two together. The way I always go is from left to right. I take the
Okay.
6, multiply it by both terms, and then I take the rest of it and multiply it by both terms.
Okay.
So what do you get?
6 times 9 is 54. Minus 12t. Yeah. Minus 45
T.
plus 10t.
Well, this term here is 45t. It's the 9 times the minus 5t.
Oh, yeah.
And then finally plus 10t squared. When you have to multiply the 5 times the 2, you have to multiply the minus 5 times the minus 2, and you have to multiply the t times the t. So how should I write this answer? What's the proper way to write it?
10t squared, I think.
Yeah, you start with the highest degree variable.
Yeah. Minus 57t. And plus 54.
Good. Perfect. Okay. About x plus 4 squared.
Is it just x plus 4 times x plus 4?
Yes. So go ahead and multiply those.
X squared plus 8x plus 16.
Very good. That you knew that those two middle terms would add to 8x without having to do that step. Let's talk about this. This is going to come up so often that it's worth memorizing as opposed to always having to FOIL it.
Okay.
A plus b quantity squared is always my cursor all of a sudden doesn't want to write. Is always a squared plus 2ab plus b squared. Likewise, a minus b quantity squared is always a squared minus 2ab plus b squared. Notice how similar they are. The only difference is the middle term. It's negative here, and it's positive there. The only reason I would like you to memorize this is because maybe you have already, and maybe that's how you got that so quick. Notice that with our x plus 4, a is x, b is 4. So when I convert it to this, I get x squared plus 2 times x times 4, which is 8x, plus 4 squared, 16.
Yeah.
So when you did it, it almost looked like you did it based on your memory of that. Did you? Or did you FOIL it? Did you actually FOIL it and then just combine the 4x plus the 4x?
Yeah.
Well, that's fine, but I would like to see you memorize that. It's going to save you thousands of seconds by the time you multiply them all up on how many times you have to do that over the next 4 years.
Okay.
So let me give you another example. What is this? Based on that. Don't FOIL it. Use this formula. What's A?
3x squared.
Just 3x.
3x.
You see why?
No.
Well, because here we have the quantity A plus B being squared. Up here we have the quantity 3x plus 4y all being squared, which makes this the A and this the B.
Yeah.
So now what is A squared?
3x.
9x squared.
Oh, 9x.
We have to square 3x.
Okay.
And what is the middle term? What is 2 times A times B?
6x.
Well, first of all, what's 2 times 3 times 4?
2 times 3 is 6. 6 times 4 is 24.
XY. In other words, this term right there is this. It's 2 times A times B. A is 3x, B is 4y. So if we multiply 2 times 3x times 4y, we get 24xy.
Okay.
And what's the last term?
8y squared.
Not 8. It's b squared. Remember, b is 4y. So what is 4y quantity squared equal to?
Oh. 16.
16 what?
Y squared.
Yeah.
Okay.
And that's the best way to do these kind of problems. Not to have to FOIL them all the time.
Okay.
But in order to do that, you have to recognize that this part is the A, this part is the B. And if it's subtracted, then we use this one down here. Okay?
Okay.
All right. Factoring. Okay. I know you love factoring. Everybody does. Actually, it's not so bad once you get the hang of it. I'm going to try to teach you. Well, you and I haven't done any factoring at all, have we?
I don't think so.
All right. Don't look at any of this. How do they teach you how to factor?
We multiply the ends first.
Do they use something called the California method or the box and diamond method or?
No, we
No?
just like multiply the. We do like 5 steps or whatever.
Good. Okay, that's the way I do it too. I don't really like the California method. Step 1. I don't know how they've taught you, but I'm going to show you how I do it, and you can make up your mind on which one you like and use it. Step 1 is to examine the m squared. That has to be m and m. Can't be anything else. Because I know when I FOIL these two things together, I'm going to produce an m squared, if there's an m there and an m there. The next thing to decide is what my signs are going to be. How do I decide that? I look at the sign in front of the number.
Okay.
The fact that it is a negative means what with regards to my signs down here?
One of them's going to be negative.
And one's positive.
Yeah.
In other words, they have to be different. They have to be different because you can't produce a negative 36 with the same signs. If I had a minus minus, then this is going to be a positive number. If I had a plus plus, that's going to be a positive number.
Yeah.
So the fact that this is a minus tells me that I got plus minus. Now, step 3. Examine your number. Find factors of 36 that subtract, because of that minus sign, to the number 5. Not to minus 5, but to the number 5. Well, let's look at 36. That's 6 times 6. It's also 3 times 12. It's also what? 9 times 4.
I think the 9 times 4.
Ah, but are you beginning to see why a calculator would not do you any good here? You have to know your times tables. In
Yeah.
other words, if you didn't know that 9 times 4 was 36, how are you going to use a calculator to figure out that 9 and 4 are factors of 36? You can't.
Yeah.
So this is one of the really big reasons why you have to know even if they let you use a calculator at all times, it's not going to do you any good here. So these are the two numbers we're looking for because we were looking for numbers that subtracted to 5. Now you put the bigger of those factors, the 9, with the sign of the middle term. Well, that's negative, so I'm going to put the 9 there and the 4 there. That's step 3.
Okay.
Step 4. I'm not done yet because I really need to check my middle term to see if it's correct. I don't need to check this term. I know that's correct. When I designed this thing, I set it up so that that would be m squared and it's m and m. I also know that that's correct. All of my effort was produced or was done to get that to be minus 36. So I don't need to check those two terms. The term I need to check is the middle term, and you do that by multiplying the two middle terms together and the two outside terms together and adding them together. Well, 4 times m is plus 4m. Minus 9 times m is minus 9m. Add those together, we get minus 5m. I call this my smiley face method.
Okay.
Because it looks like two smiley faces. Okay, and that's it. It's very straightforward. When you have simple quadratics like this, as the quadratics get more complicated, the factoring gets more complicated. But let's work with the simple ones as long as we can. What's going to complicate it is if we get a coefficient in front of the x. Okay. This is a quadratic, but it's missing the x term.
Yeah.
Doesn't matter. It still can be factored. In order to factor this, you have to recognize that it's called the difference of perfect squares. This is a squared minus b squared, which always factors into a minus b times a plus b. What is a in our problem?
X squared.
Just x.
Oh, okay.
See why?
Yeah.
What's b?
64 minus 64.
8.
Oh.
In other words, a is always the square root of that, and b is always the square root of that when you have a difference of perfect squares situation.
Okay.
Okay, because this over here is a squared. Well, that's x squared, so x has to equal a. So how does this factor? If a squared minus b squares factors into a minus b times a plus b, what does x squared minus 64 factor into?
X minus 64 minus 64 or 8.
Remember, it's a minus b
Okay.
times a plus b. That is fully factored.
Okay.
Very easy to factor. Whenever you have difference of perfect squares, it's very easy to factor. It's not hard like that one was. Let me give you a couple others. Factor that.
Okay, x minus 4,
Not 4.
2.
Remember, we always want the square root of that and the square root of that.
Okay.
Times what?
X plus 2.
Mm-hmm. How about one that a lot of people don't recognize? The reason they don't recognize it because this is the difference of squares. They don't recognize it because they don't think of 1 as being a perfect square, but it is.
So is it x minus 1? And x plus 1? Um, 4x.
No. Take the square root of that whole thing.
I don't know.
2x.
2x.
That dog barking at your house or mine? It must be your house.
Yeah, it's mine.
Okay. So it's 2x. Excuse me, I meant to put a minus sign here. It has to be difference of perfect squares. Sum of perfect squares does not factor at all. If I'd have left the plus sign there, there's no factoring it. But with a minus sign, it's the difference of perfect squares. 4x squared is a perfect square. What goes next? My dog's very interested.
Yeah.
There's a dog in this computer somewhere.
Yeah.
You can hear it. What's the square root of that?
3. Okay.
You see what we're doing? Always taking the square roots of these things when we factor this.
Four.
For what?
4x.
Notice that 4x squared is 16x squared.
So minus 9?
Yes.
Okay.
Times 4x plus 9. Okay?
Okay.
All right. Now let's go on to your next problem, which was 6x squared minus 7x minus 3. Okay, now things become a little more difficult. The reason is that we no longer have a coefficient of 1 in front of our first term. So we need factors of 6 to get started. So what's going to go here and here? Can't be x and x because that would only equal x squared.
3x?
Okay, that'll work there. What would go here?
I don't know.
It has to be 2x. In
Oh,
other
okay.
words, our goal is this times this has to equal this.
Oh, okay.
So we're splitting this 6x squared up into two products. You know, when I FOIL these back together again, I'm going to start by multiplying 3x times 2x, and I'm going to get this 6x squared term. So all we're doing is in reverse. Okay? However, now everything is different. I not only don't have a coefficient of 1 in front of each x, but I have a different coefficient from the other one. This one's 3, this one's 2. However, the next step is still to figure out my signs. What does that mean about my signs?
One's going to be negative and one's going to be positive.
Yeah, but in this case, I can't automatically do that because of the difference in coefficients. It might be this way. In other words, I might need the minus over here and the plus over here, or the plus over here and the minus over there, and it's going to produce different answers. Back when I had just an x and just an x, well, plus minus is the same as minus plus. So there's no need to account for either way. You just can put plus minus. But the moment I have a coefficient in front of that that's different than this, I have to allow for all four possibilities. What's the next step? That was the second step. Remember,
you find two terms that make -7?
No. In other words, the next step is we're looking for factors of 3.
Okay.
Well, there's only 2 of them, 3 and 1. That's it. And we can no longer make those statements. I can no longer say that subtract to the number 7. I can only say that kind of stuff if these coefficients are 1. The moment one of them has a coefficient different than 1, I can't make those statements like I could before. And my only choice is to just start trial and error. Don't have a lot of options to try. I can try 3 there and 1 there, or I could try 3 there and 1 there.
Okay.
Well, let's just automatically try the first case. What middle term does this produce?
-6x. 3x.
Add them together. Add them together.
-3x.
So that's not right.
Okay.
In other words, this isn't minus 7x. So that's not our solution. And in fact, it wasn't even a 7.
Yeah.
So let's try switching the two numbers. Putting the 1 there and the 3 there.
Okay.
Now let's check.
Is it x?
Let's do it piece at a time. What goes here? What's minus 1 times 2x?
-2x?
What's 3x times plus 3?
6x?
9. 3 times 3 is 9.
Oh, okay.
So that's 9x. Add those together and you get plus 7x.
Okay.
So we're still not right, but we got the right number, and that tells us enormous things. That means is all I have to do is move those numbers down. Make the 1 the plus, make the negative that. And that is going to work. And because I've switched it, now I have a plus 2x and a minus 9x gives me minus 7x.
Okay.
That's my smiley face method for solving this problem. And there is one caveat here. This does not have to be 3x times 2x. could have been 6x times 1x.
Okay.
That didn't work. But when I factored that to begin with, I always start with the two factors that are closest together. In this case, 3 and 2 are closer together than 6 and 1.
Okay.
But had we not been able to get this to work using 3 and 2, my next step would be to go back and change it to 6 and 1 and then try it with all 4 combinations. Okay? So you can see that it's a lot harder when you have coefficients in front of the x. I can never make any statements like factors of this number that add to this number or factors of this number that subtract to this number. All that goes out the window. The moment you don't have 1 and 1 as your coefficient. Okay. The arch of balloons is tied to a frame. The frame can be modeled by that equation where x and y are measured in feet. X-axis represents the ground. Solve the equation for x. Here's our equation. Solve the equation for x, find the zeros. When it says find the zeros, what are we going to set equal to 0?
Minus y? Or yeah, we minus y.
Just y.
Y.
Just y. Oh, I did leave a minus. Oh, there, the minus sign's over here. Yeah. So, I'm just going to make that 0 and solve the equation.
Okay.
What's the first thing I can do to make this thing a whole lot easier?
Add the x's together?
No, basically this coefficient is kind of meaningless because I can turn it into 1 by multiplying both sides by whatever I need to turn it into 1, which in this case is negative 8/5.
Okay.
It doesn't really matter because I'm going to multiply the left side by that same number and it always stays 0.
Yeah.
So basically what I know is that I don't care what I have to do to get rid of that 5/8, I'm getting rid of it and it's not going to change anything. In other words, I can immediately say that. What I technically did was I multiplied both sides of the equation by minus 8/5, turning this into 1. Turning the right side into this, the left side stays at 0. Now, how do we solve that?
Do you just multiply?
No, we just unmultiplied it. Well, no, we really didn't. We were given this equation. But we don't want to multiply it together because that would turn it into a quadratic, and the way to solve a quadratic is by factoring. So this one's already been factored.
So do you times x by...
No, there's the principal law of algebra is at play here. The principal law of algebra says that if you multiply two quantities together and it's equal to 0, what? That's exactly what we're doing. We got one quantity times another quantity equal to 0. What has to be true? Either x minus 2 is equal to 0 or x minus 10 is equal to 0. Solve both of those.
Okay. X equals minus 2. 2.
You have to add 2 to both sides to get
Okay.
x down to just x.
So x equals 10.
That's how you solve it. In other words, whenever
Okay.
you hit this step, whether it's given to you or whether they started out with a quadratic that you factored, the next step is to always set both of the things that are being multiplied together equal to 0, each one of them. Because you
Okay.
can't produce 0 without one of these being 0. It's impossible. How do the solutions relate to the graph? We just found the zeros for x to be 2 and 10. So what does that mean for that graph we're looking at?
That's a 0 point.
Right? So they're right there and right there. So what's that value on the x-axis?
0.
No. What were my solutions?
Oh, 1.
No. What were my 2 solutions?
2 and 10.
There's 2, there's 10.
Okay.
In other words, the zeros are the x-intercepts, remember?
Yeah.
That's what it means to have the zeros, is that's where it crosses the x-axis. So it's crossing the x-axis at these 2 answers, 2 and 10. Find the width of the frame at ground level. Well, here's the ground. There's 2. There's 10. What's the width right here?
8.
Uh-huh.
Okay.
So, find the dimensions. Hold on. So find the dimensions of the rectangle when the area is equal to 32 square inches. How are we going to do that?
Multiply the base and the...
Good. Because area equals base times height.
Yeah.
Well, they've given us the area is 32. What's the base? X minus 6. What's the height? X minus 10. Solve that equation. That's a quadratic. In other words, when they said find the dimensions, they're not saying it's x minus 6 times x minus 10. They want us to solve for x so that we know the exact length of the base and the height. So let's look at this equation that we just wrote. Our goal is now to solve this. So what's the first step for solving it?
6 times x minus 6x.
That's not the first step. The first step is to multiply these 2 things together. Foil them.
Oh, okay.
Always use the same, always start, in other words, don't start in the middle like you just did.
Okay, x minus...
No. What's this term times this term?
Oh, x squared. And then negative 10x minus 6x minus 60
Plus 60.
plus 60.
Still have our 32 over there.
Okay,
How are we going to
minus
solve?
16x.
Okay. So how do we solve this? We have 32 equals x squared minus 16x plus 60. What's the first step?
Minus 60.
When you have a quadratic that you want to solve, almost always, unless it's difference of perfect squares, almost always you set one side equal to 0 and everything else on the other side, which you then factor. The reason being is that you can solve it if two things are equal to 0. If I factor this expression, I don't need to factor it because it came factored. But when I tell you that x minus 6 times x minus 10 is equal to a number, I can't solve it. But if I tell you that a quadratic is equal to 0, I can solve it. So how do I make one side equal to 0?
Zero it?
Subtract 32 from both sides.
Oh, okay. So minus 32.
What's 60 minus 32?
38.
28.
28.
Always add them back together. Make sure they equal what you had. Okay, now this is just one more thing to factor. In other words, our goal here is to solve for x. Once we solve for x, we'll know what the dimensions are, because the dimensions are x minus 6 times x minus 10. So we got to solve for x. So this is different. We haven't looked at one that had a plus. So what's first step?
X plus 16.
Hold on.
Oh, X.
Always put both of them. Don't try to solve that alone.
X and X.
Yeah. And what's the second step?
Plus 16.
No. Figure out the signs.
Oh,
Is the
plus,
second.
yeah, plus.
Well, they're not plus. This plus means that both signs are the same.
Oh, okay. And then is that then both negative then?
Yes. In other words,
Okay.
once you've determined they're both the same, you look to the middle term to figure out what they are. So it's minus and minus. Now, because we have coefficients that are 1, I can go back and I can use my little rules. What's my third step here?
Plus 16.
Factors. Don't forget the word factors. I want factors of 28 that do what?
That add together and multiply together to make 28.
Not both. Just add together to make 16. They multiply
Okay.
together to be 28, but they add together to equal 16.
Okay.
Okay? Instead of subtracting to 16, if this was a negative sign, they would need to subtract. We know they need to multiply to 28. That's what factors of 28 means. That's why I would like you to use that expression, is because the third step at this point is we want factors of 28 that add to the number 16, and then we'll be done. So what are factors of 28?
2 and 2 and 16.
2 and 14.
14.
And 2 and 14 add to the number 16.
Yeah.
That's my answer.
Okay.
Because other factors would have been 4 and 7, but those don't add to 16. So, what is my solution? What is x equal to?
X equals positive 2.
Or,
Positive 14.
if we look at our picture, can x equal 2?
No.
Because that would give us a negative dimension. And whenever
Yeah.
we're dealing with dimensions, we have to keep everything positive. So this solution, x equal 2, isn't a solution. That's called an extraneous solution. I cross
Okay.
it out. The only one that I'm going to use is x equal 14, which makes my dimensions 4 by 8. which gives me an area of 32.
Okay.
Okay. Julian, I'm going to have to run. I got another appointment.
Okay.
But this is good. Keep all these problems coming. We want to run out of problems before, I'm sorry, we want to run out of time before we run out of problems, which is what we did tonight. Last week we ran out of problems before we ran out of time.
Yeah.
This is always better. And
Okay.
it looks like you're making some progress. I see it.
Okay.
Okay? I will talk to you next time.
All right. Thank you.
All right. Bye-bye.